and the last one is called Spark. Okay, I have given some definitions for these cases. The cases are individuals from which the data are collected. A variable is a characteristics that is measured and can take on different values, depends on the person. Okay, in other words, something that varies between cases. Okay, and the last one is the summarizing of the data. Okay, comprehension is compression, which means that if you are telling that I understood something, you should be able to explain it very simple. That is the words of Einstein. You may heard that. Okay, so the same thing. If you are telling that I'm having some knowledge from the data, you need to be able to compress them, and then you have to give out that knowledge. Okay, and that is what we call it as summarizing data. Okay, you can summarize the data visually as well as numerically, and visually summarizing the things is called presenting the data. Okay, you can use graphical methods as well as tabulation methods. And when it comes to summarizing data, we're going to see about the distribution. This is all about the distribution. I said about the distributions, right? The distributions are very much important in statistics, right? And the characteristics of the distributions are measured in terms of these measures, like measures of central tendency, dispersion, and shape. Okay, so we we will see all these things in the collab session, and then you will get to understand what is everything. Okay, so distortion. Okay, is there any doubt? Like, am I went so fast? Can you able to catch me?
Yes, of course. The following.
Like, do you have any doubts?
Not for me.
Okay, so we can. Okay, we can move on to the collab session. I'll show you a small demonstration of. Okay, is my screen visible to you?
Yes, sir.
Yes.
Okay. So this is what we call it as collapse. So this may be new for many people. And this is a project by Google, and they are offering it for free for use. Okay, and you can use it for your development in artificial intelligence or just to learn programming. It is a very handy tool. And then the collab is visible, right? This notebook file.
Oh,
Can
yes.
you,
You can actually share it in the
okay,
chat so that
okay, the
it-
link, right? Okay. Okay, so this is the collab link. If you wish, you can open it, but I wish you should observe the things, because then only you can know what you are doing. Okay, so let me give you a small introduction about what are the features that is available in the collab. Okay, so collab is more like a document file where you can create titles. Say for example, if you want to have a heading here, you can use this one. If I put this is a heading, this will be a heading. Okay, and you can create content based on that. This will be have a table of content. Okay, and then you can do a lot of formatting here. Like if you want to bold it, you can just select it and then click the bold button, and that will bold your text. And then if you wish to italic it, and then it will make italic format. And then if you want to add some codes here, you can use this to add your codes. Like this is a formatted code. You can add links, then you can add images, and you can bring some codes, and then you can add some number list, unordered list. You can have a horizontal line. You can bring latex, which means that you can bring, it is a markdown language where you can use it for writing equations here. And then I think it's for some emojis. Okay, and then you can reposition this markdown. This is the preview. So if I click this button, you can see it is going down. If I'm clicking it back, it will be in the sideways. Okay. And then I'm going to delete this cell. So it is not useful for us. And then you can see we can open the files that is located in our drive, and there is a playground mode. You can open new notebook, you can open your previous notebook. You can, if you are having a IPyNB like Jupyter notebook file, you can upload them and then you can open it via Collab. Okay, and then you can rename it, you can save it, and you can download the notebook file. And here are the options for editing, viewing, and then you can insert cells, and this is for the runtime. So basically this Collab is operating on Python. So that is the interpreter that is inbuilt in this Collab. So you can use this to run the cells, which means that you can get the outputs of Python. And then you can use some tools like command palette. You can have a terminal here, and then you can get some help. And then what else? You can share with people. Yes, it's about collaborating with the people, right? You can add some people, and then you can collaborate with the others. Okay, and
Okay,
then this
asking for the link.
I posted it, right?
I don't think.
Oh, sorry. Actually posted for a particular person, not for everyone. Is it available now?
Yes, we can see it now. Thank you.
Okay. So, okay. So if you see, you can change the theme of the editor, like what we call it is like a IDE, integrated development environment, where you can write the code as well as you can run it. And then you can change it to dark mode, and then you can change the appearance. Okay. So you can get AI features also. You can you don't need to go to ChatGPT for asking some questions. We have Gemini here, and then we can add GitHub, and then you can get your repositories here. And then in miscellaneous, you can add some cute things like if you click this button, you can find some cats and dogs that will go here and there. See, like this one. Okay. So what I need to tell more is change the right runtime type. Okay, so you can use R in Google Colab also. You can use R, both Python in Google Colab. And about the hardware accelerator, we are using GPUs. I mean the CPUs here. CPUs for basic computational tasks can be done with CPUs. What's this GPU for? For processing the image, like using computer visions, no? So in that case, you can use GPUs. That will enhance your performance. Okay. The last one is called the TPUs. TPUs is for processing, tensor processing unit. When it comes to deep learning, you will have a thing called tensors. It's like a big multi-dimensional matrix. You can process them with the TPUs. Okay. So this is about the collab. You can have a file path here. You can upload the files. You can refresh it. You can get your Google Drive files here, and then you can track the variables that is in your program, and that's it. And if you want to collect, if you want to use the Google Colab, first of all, you need to see this one. You need to connect it. There may be some connect option is available in your Google Colab. So if you click this button, it will be connected to their servers. Okay, and then you can see what is the RAM, what is the disk storage that is used by your programs. And when you are using Google Colab, there is a big advantage. It's because you don't need to uh, use your own internet to download anything. Okay, so you will use the remote service data and their transmission speed. You can even get data of size 20 GB, and then you can use it here in Google Colab for your analysis. Okay, is that fine? Is there any doubt in Google Colab? Shall we proceed? Okay, I forgot to mention about this coding part. So maybe we can start this one. So this is a cell where we can code. If you see, I just typed print, but you can see a suggestion from Gemini. That is, you want to make it like hello world. Okay. So all I need to do is I can run this cell from the runtime, or else there is a play button over here, right? So if I click this one, I can see the Python output. Okay. So far, do you have any doubts about the Google Colab?
Good morning, sir.
Yes.
I want to know if I can use my smartphone to do the Google the Colab, because I'm taking this lecture with phone. Thank you.
It's okay. It's okay. First of all, the thing is that I'm always emphasizing is you should understand. It's not about the practice. Like if you want to just practice, you need to write all the codes on your own. Okay, but you are not trained in that way. As of now, your level is not in that much, right? So you are a complete beginner, right? So you have the codes already written here. You just need to click this run button and then see what is happening here. Okay, that is the important part. Okay, so you just please listen
Okay.
what's actually going on here. Okay, so shall we start proceeding with the collab file? Am I taking so much time?
No, so
Proceed.
time, you can go ahead.
Okay, so this is a data set that is collected in 1936. It is not actually collected by Ronald Fisher. He is considered to be the father of modern statistics. And for your information, today is the National Statistics Day of India. Okay, it's because of famous statistician of India called Mahalanobis, and his birth is observed as National Statistics Day of India. So, like him, there is a person called Ronald Fisher. He's a very great man in the statistics field, and he used this data for discriminant analysis. But the data is actually collected by Anderson, uh, where this data is about a particular species called iris. It is a flower, and this is a genus, and it will have three species. One is called Setosa, Virginica, and versicolor. Okay, and this data set have data of 50 samples from each of these species. In total, it will be 150 records. Okay, so I hope you understand what is the term record, cases, and variables, right? And there will be four features that is in present in the actual data set. One is the length and width of the sepals and the petals. Okay, this is a data set, what it looks like, and this is the flower. Okay, and this is a sepals, and then this one is the petals. And this data will have the information about the length of the sepal, and then the width of the sepal. Then same for the petals. Okay, and then, as I mentioned earlier, these things are called features, right? Okay, features. And this is a case label, which will be helpful on deciding whether this data belongs to which species. Okay, whether it is Setosa, versicolor, or the other species. Okay, so these are the three flowers: Setosa, versicolor, and virginica. It is their petals and sepals. Okay, if you want to get the data, you can click this button, that is the download data set. If you click this one, you will get a CSV file. CSV stands for comma separated values. And then after that, after downloading it, you have to upload this file here. You need to locate the file and then click open. Now you can find the file here, right? Then we can run the cell. So if I click Control plus Enter, this cell will start to execute, right? You can see the data frame. This is what I said about the data frame. This is the data frame. Okay, this is more or less like a table, right? So with the help of pandas, we are loading this data frame into our Google Colab notebook. Okay, so where you can find the length of the uh, chapels and width of the chapels and then petals. And then I added two features additionally apart from the original data set, that is the number of petals and the number of chapels. This is for our further analysis. This is completely random. This is not the original feature of that flower. Just for our understanding, better understanding, I just added this one. Okay. And if you see, I added a thing called a head. This is called a method in Python. Okay, so if you use this head, it will show you only 5 records of the data set. If I remove this one, you can see the entire data set. Like it will have this 150 rows and 7 columns. And if you click this button, you can see the entire table. It is processing now. You can see the entire data is located here. Like now I'm able to see 25 records per page. Even I can increase it to 50 and you can see it is getting longer. And if I increase to 100, it is getting even more longer. Okay, this is how you have to bring the data to your Google Colab. All right. So we have a thing called shape. This is called an attribute of a data frame. Okay, in Python it is called as attribute. This will be more explained in the object oriented session. Okay, so this is an attribute. So in this data frame, if you just call this attribute, you will get something like this one. So this 150 represents the number of rows and 7 represents the number of columns. Okay, so and then you need to find is there any empty cells like where there is no data. You can find it by using this particular method, that is null, and then you need to add everything. That will give you a value like sepals having 0 null values and width having 0 null values. None of our variables is having null values. So that is a very good thing. If you are facing some issues with the null values, you need to look up into these methods called imputation techniques. Okay, so it's a very big topic and you can explore it on your own. Okay, and when it comes to organizing the data, so we know that forming some frequency tables, right, for continuous data and then for some qualitative data. That is what we're going to do now. So I'm going to start with organizing the data of a quantitative data, that is a sepal length. So why we call it as a quantitative data? You can see the sepal length is a continuous data, which is actually not a single discrete number. It is actually continuous data. Even if you are having a more precise scale, this number will go on. Okay. So first of all, we need to find the maximum and minimum of this cells, and that is 4.3 and 7.9. This is the maximum length of sepal length and the minimum length of the sepal length. Okay, and then what we have to do, we have to find the class width. Okay, so finding the class width. If you remember, I have shown a class intervals in a table, right? So you need to calculate what is the length of the width of the particular class interval. What is the difference between the upper and the lower limit? So for calculating that, there is a standard procedure for that. The basic formula for calculating a class width is maximum minus minimum divided by the number of class intervals. But how can we decide the number of class intervals? So that can be decided based on a formula called Sturge's formula. So basically I have given the formula here. You just need to give the number of samples. Here in this case, it is 150, right? You just need to put it in the formula and that will give you a result. Okay. In that case, it is showing as around 9 samples is required. Like you can try these online tools where you can calculate the sample size and the number of class intervals here. Okay. And also to classify, like if you want to organize the data in terms of the class intervals, you need a thing called bins. Bins represents is like a buckets. In that buckets, you can put the data. If it is 5.5, you need to put the data in the 5.5 bucket. Okay. So to measuring that, I have created a small program for that, and this will take the maximum value and minimum value and the number of samples, and then it will give you the exact buckets and the class intervals directly. Okay, so if I run this one, you can see I'm getting this output, and I'm asking for a qualitative data frequency table. You can see I'm doing it by value underscore counts. This will give you the frequency of each of the categories. Like setosa is 50, versicolor is 50, because that is a category. It is not a numerical data, isn't it? So we can get the counts, like the frequencies of these categories, by using this method called value counts. Okay. And then you can arrange them as well by using the sort index. It will arrange them. And then what here we are doing is a discrete frequency distribution, because I said it represents the number of petals, right? Number of petals. So number of petals is not a categorical data. It is actually a numerical data, but I cannot say that number of petals is 2.5 or 3.5, right? I have to tell something like 1, 2, 3, or 7 or something like that. Okay. In that case, you can use the same technique, and then you can use the sort index that will give you the discrete frequency distribution. You can see how the frequency is distributed along these values like 3, 4, 5, and 6. Okay. I always emphasizing that distributions are very important in statistics. Okay. So this is how you need to know how the values or the samples is distributed along these values. Okay. And then we can construct a continuous frequency table using this function, this program. So if I run this one, you can see from 4.3 to 4.7, you can find 9 observations, and then 4.7 to 5.1 of flowers having a sepal length will be 23, and then 5.1 to 5.7 will be 20. So this will give you the continuous frequency distribution of the data. Okay. And then if you want to know details of a particular observation, you just need to do a simple thing. You have to call this method that is iLocation, like ILOC, and then you need to give the case ID, okay, or the row ID, or row index. That will give you the length of the flower, the width of the flower, and the petal length, petal width, and what is the species, what is the number of petals, sepals, everything will be available here. Okay. And if you want to remove some of the columns, you can use this particular function, that is drop. And if you notice, we have created a continuous distribution, no? So if I again run, if I check my data frame, you can find a strange thing. That is, previously we don't have this sepal pins. Now, after making the continuous distribution, we have the sepal bins, which means that the program will automatically look into the value of sepal length, and then it will give the category whether it belongs to this particular thing, and then it will give a count of how many values are present in this particular interval. Okay, so I don't want this particular column. I can delete it by just running this one, because I'm using the method that is drop. Okay, so if I again check my data frame, you can see the sepal bins is gone. Okay, and then you can drop a list of columns by using a thing like this one. You can specify the column index and then delete all the columns at once. Okay, so let's see about how we're going to present these distributions. Okay, so the library that I'm going to use is called matplotlib, and then I'm going to create a histogram. Histogram represents the distribution of a continuous variable. Here it is the sepal length. You can see how the sepal length is distributed in this way. Like the frequency is measured based on the height of this particular bar, and that will bring some shape. You can find some different shapes of these histograms. Okay, petal width also will have some different shapes and all. Okay, and then if I want to, but actually you should not use histogram for the case of discrete variables, because it won't have any continuous data, right? So we can use petals and sepals or discrete variables. So in that case, we have to use bar chart. Anyway, the histogram itself is look like a bar chart. Okay. And then we can see the distribution of the histogram, like the values of the sepal length among each of these particular species. You can see the Setosa is having a different distribution over here, and versicolor is having a different distribution over here, and Virginica having a different distribution, which means that all these species are not same. They are having some different difference in their own nature that can be seen from their distributions, because not all, everything is coincident. No? It is actually separate, which means that there is a natural difference that is in among this species. And for time being, I'm going to skip this one. Like it is a scatter plot. This will help you to find a linear relationship between two variables. Not going to very much detail about it. And then you can see a distribution of the sepal length. This is the overall distribution, and this is the distribution of each of the species. Okay, and you can look into the code after if you are having some free time. Okay, because this is a technical things that you can find in Google, and you can find some explanations why some methods are working in this way, and what are the arguments that you're going to provide under this function to get this output. Okay, the next one is called a stem and leaf plot. What it will do, it will create a stem. This is the stem, that it is like a part of the number, and then it will create the remaining data points, and it was more like a data representation. And if it is like 3 4 and 3, it represents 4.3. If it is like 5.0, it is 5 and 0, it represents 5.0. Like that, it is like a representation of the data. Okay, and when it comes to measuring the center and variation, it is a very much important part of the summarization of the data. So far we have seen so much about the distributions, right? And you need to know what is the thing that is deciding the distributions. Okay, so every distribution will have a center. So the center can be found with a measure of mean, median, and mode. You can use there is a thing called normal distribution where these all things will coincide, but for some general cases, all things represents a different thing. So mean represents, you already know what is the average. You need to add up all the values, and then you have to divide it by the number of samples. That is what the mean represents. What is a median? Median represents, you need to arrange the values in ascending or descending order, and then you have to find the middle value in that distribution. What is the mode? What is the most frequent value that is in that particular data set? Okay, that is what this central tendency means. Okay, so if I say the median here, this stem plot will be very much used to find median or this mode. So by the plot itself, we can find that this data is arranged properly in ascending order or descending order, because it goes from 4 to 5, and the values are like 4.3, 4.4, and 4.9, 5.0. It is arranged perfectly, right? So to find that, we know that there are 150 observations are there. So the median lies between around 150 by 2, right? So if you find 22 values are there, so 150 by 2 around 75, right? So 22 plus, if you find the 75th value, you can
With
get
you,
something
maybe
like,
say,
hello? You can find something like 5.8 as the median. Okay. So the data vary. Do you have any doubt? Okay, I'm proceeding. Okay, so when it comes to data variation, you don't need to just only know what is the central value. You need to know how much the data is varying, right? So in that case, you can use a measure called measure of dispersion or measure of variation. Okay, it's like a average of all the differences. Okay, say for example, if the mean value is like 5 points and people are getting something like 3, 2, 1, 4, something like that. Okay, and if you want to measure the variation of this data, you just need to subtract 5 minus 4, and then 3 minus 5, and then 2 minus 5, and you can take an average of all the differences, and that will give you an idea about the variation of the data. Okay, so all these things can be seen here. And then important thing about the distributions, theoretically there are many distributions in probability. Initially I asked some questions about probability, right? So in probability there are some theoretical distributions. We call it as normal distribution, Poisson distribution. There are so many distributions out there. And if you see, this is a example of a normal distribution, and a thing that determines a distribution is called a parameter. Okay, so if it is like a entire population, and a constant that determines a distribution is called a parameter of the distribution. Okay, so this normal distribution will have two parameters. One is called a location parameter, and another one is called a shape parameter. Okay, so this location parameter decides the position of the graph or the curve. And you can see the position of the graph, the central position of the graph is 0 now. So the parameter of this normal distribution is mean. So if I say, if I'm changing this 0 to something like 20, and then I'm running it, you can see now it is not 0, because the distribution depends on the mean. That is a parameter. Okay, and then if I change, and you can see you can even adjust the spread of this distribution. Say for example, if someone is asking what is the average score of a class, you can give some number like an average number. Like you can calculate sum of all the scores, and then you can divide it, and you can give a single number to represent the score of the entire class. But what if we have two classes and having the same average? Can we say that both of the classes are performing equally? In that case, you can use the dispersion. It's because you can see the class A will have a dispersion that is very low dispersion, which means that most of them is around the central value. And for class B, the dispersion is very low, which means that even though the mean value is some number, you can see there is a variation among the performance of the students. That is not the case in the class A. Okay, you can change that by adjusting this particular number. And one more thing is that the distribution of the normal distribution is depends on standard deviation also. Okay, standard deviation, if I change this one, you can find that previously it is 5, now it is like the variation is 10. Okay,
Hi, Deepan. Can you hear me, please? Sorry to cut you
yes,
short.
yes.
Okay, how long do you have left to round up? We are behind time a bit.
It's okay, it's okay. I know that it's a very big topic,
Yeah.
and 15 minutes is not enough to cover everything.
So can you round up in like a few minutes,
Sure.
like 5 minutes or so?
Okay, let me finish this by a small story. Okay, we need to
Thank
know
you.
why. Yeah, we need to know why we are doing all these things. Okay, so this is a
All right.
person. This is a person named John Grant. He's from around the time 1400 to 1500. Okay, he's considered to be the early user of this statistics. Okay, so what he did is in his time, what they will do is they will publish a thing called the bills of mortality. And then he found that this black plague is a very deadliest disease of that time. So he collected the data based on these bills, and then he gave some estimation of the population. This is just an application of what he did in that early time. So you may want think that why we need to study all this stuff, right? So this is one of the reasons why we can see that the statistics can be useful for estimation of the population. And this is a table, like this is called a life table by John Grant. This is used for calculating annuities. It is like opposite of life insurance, which means that you just need to give a wholesome money, and the company will give some monthly rent, a kind of some money for you till you die. Okay, so those things can be calculated based on his table. And there are a lot of things that you can study about statistical distributions, and everything will be covered in this book. Okay. And moreover, or I don't know whether it is we are having time for doing this p-value. Anyway, shall we wind up this one?
So can you touch on p-value?
Okay.
Because we have a quiz. We have a quiz for that p-value when we are taking attendance.
Okay. So, okay. So what this inferential statistics, this is just some introduction to inferential statistics. So what inferential statistics people will do, they will have some hypothesis. Hypothesis is that they will do some research, they will have some question in their mind. Okay. They will frame the hypothesis and then they want to test whether this hypothesis is true or not based on the available data. So this p-value is a tool which can be helpful for them to understand, which will be helpful for them to conclude whether the hypothesis is true or false. Okay. For example, you see, this is an incident that happened in 1600s, like 17th century, by John Arbuthnot. What he did is he had a hypothesis, like there is some bias over the gender distribution. Like there are more males than females. This is the general hypothesis that he had in his time. But what is the hypothesis that he framed? Let me run this thing. So generally, if you see, the hypothesis that he framed is a null hypothesis and the alternative hypothesis. Null hypothesis means that there is no difference or you're not favoring for any party, which means that I'm telling based on according to the nature, both the proportion of males and females are equal. Okay, there is no gender bias. We don't know who is going to born, whether it is a male child or a female child. We don't know that because we can say that both of them is having 50-50 chance of their birth, right? But what he is telling, I'm guessing that males having a greater proportion of the birth. Okay. So this p-value is like a probability value of observing the particular data when the null hypothesis is true. Okay, so he collected the data for 82 years. Okay, for 82 years. The surprising part is that in all over 82 years, this is the data that he collected. In all 82 years, the male gender dominated the female gender. This is actually so much surprising. According to the nature, you can expect even any females or males having equal chance of dominating any particular area. But how it can happen in all 82 years, like the males only dominating, right? So he then calculated the probability of the occurrence of this particular event. Okay, so the probability for dominance of male is 1/2, right? Because 50-50 chance. For 82 years, this male dominance will be 1/2 whole power 82, which will give you a very big number that is given here. This is that very big number that is 1/2 power 82, that is equals to 2 into 10 power minus 25, which is actually a very small probability for this event to happen. So it's like this event will happen in only one time of 170 quadrillion universes. So even one universe will have multiple galaxies and we are living in one galaxy. Likewise, there will be 170 universes, I mean quadrillion universes. In that case, this event will happen only once. Okay, so this p-value is basically telling you, if I'm telling that null hypothesis is true, then what is the chance to have this data that I'm having right now? So now you can make a guess, like the data that that person is having is very low. That is 0. Like 0. I mean 2 into 10 power minus 25, right? It's a very low probability thing. So I can say that this is having a very less probability. So the null hypothesis is not true. I can go with the alternative hypothesis, which means that the males are having some partiality over the females, which means that there may be some female feticides and other things. But now you can understand how these p-values will be helpful for deciding whether to reject or accept a hypothesis. Okay, so this is about the p-values, and if you have any doubts, you can ask.
Okay, are you done? Hi, Deepan,
This,
can you hear me?
yes.
Okay, you're done, right?
So this is actually a very much challenging session because statistics is, I'm just trying to
Yeah.
cover the bachelor's
Yes,
thing in
yes.
just 50 minutes. It's not a easy thing.
Yeah, I understand. Okay. Thank you so much. Of course, it's not possible to do so much in a short period of time. So this is just this is just the little we can cover within the short period of time. So we're going to have like 5 minutes break, and then we're going to get to the next section.
I think some person is having some doubt about type 1 error and type 2 error.
Yeah, we can. Why in that 5 minutes they can ask questions, and you can respond to them within that 5 minutes. So the 5 minutes is both for break and both for few questions. So if there are questions you can ask, you can drop it in the chat box.
Okay.
And someone can respond. You can also ask if you want to speak too. So we have 5 minutes. Thank you so much.
So I said about accepting and rejecting hypothesis, right? Hypothesis is just a statement about your research. Okay. What is this true? Type 1 error. Let me erase everything. Can you able to see my screen?
Yes.
Okay. So what is this type 1 error? Well, basically, if I'm doing a research, and then I will have some questions in my mind. So based on the questions, I will frame some hypothesis. So without any partiality, the hypothesis I'm making is called a null hypothesis. And the thing that I'm having in my mind is called the alternative hypothesis. Okay. So you asked me what is this type 1 error? Okay. By the name itself, you can understand that there is error. Error means mistake. So what is the mistake that we're going to do? Okay. So the mistake is that you going to reject the H naught. H naught represents the null hypothesis when it is true. It is called the type 1 error. You understand? I'm telling that there is no difference between male and female. Okay. And then you are making a conclusion that yes, there is a difference between male and female. And that kind of mistake is called the type 1 error. Is that clear? What about the type 2 error? Is that you are accepting a H naught, accepting the H naught when it is false. We can show you some examples. This can be a very easy example that we can understand. Oh. Oh, can you see my screen? Okay,
Yes.
so this is
Yes.
So I said about it is about the mistakes, right? And imagine as an analyst you are a doctor, okay, and what you are doing is giving someone's like you are pregnant. It is one type of error, okay. And then the second one is called the which means that rejecting the H naught, which means that he is not pregnant. He can't be pregnant. That is what the alternative says. And you are telling that you are rejecting it. Okay, you are rejecting he is not pregnant. Okay, that's why it's called as type 1 error. And what is this type 2 error? Is that you are rejecting some truth. Truth in the sense rejecting the correct alternative hypothesis. Alternative in the sense if someone is already pregnant, but you are telling that you are not pregnant. Okay. But what people are telling is that this type 2 error is more serious than type 1 error. Okay. Is it clear? Like, should I explain it more?
It's clear now. Thank you.
It's clear, but please, may I ask a question?
Sure.
Okay, I just want to get a name for the other hypothesis. The first one is the null hypothesis.
Okay.
And the second one, what's the name, please? The H and the I or something.
Okay, it is that alternative hypothesis.
Alternative, all right, thank you.
Okay. So the representation is HA or H1.
Hello?
Yes.
Yeah, if I understood you correctly, there was one example you used where even though there was the probability of the males dominating the population, the p-value was so little.
Your voice is not so clear. Not able to understand you.
Hello? Can you hear me now?
Yes.
Yes, I am saying there was this example in your presentation. You showed where, based on the statistics the person had, it appeared that the males dominated the population for about 82 years, but the p-value indicated that the value was so little, so it meant that the null hypothesis would be rejected. So my question is, what value can you get of the p-value that will make you accept the null hypothesis, even if it is?
Okay. So you are asking me by what? Okay, I think you are asking about how can we reject hypothesis and accept hypothesis based on the p-value. Am I correct?
Yes.
Okay, so there is no rule like based on the value we can reject the hypothesis and accept the hypothesis. But what conventionally as a like a beginner statisticians will do, they have a threshold for 0.05. Okay, this is actually defined by R.A. Fisher. Okay, which means that if the event is happen in 1 out of the 20, you can call it as like if your p-value is goes less than 0.05. Okay, that case you can accept the alternative, which means that you can reject the null hypothesis. Got it? Reject H naught. If it is greater than 0.05, you can accept the H naught. So basically, what this p-value is telling about whether this data that I observed is generated randomly. Okay, so what it means that this 1 by 20 is actually 0.05. If the p-value is less than 0.05, I cannot tell that this is actually generated randomly. There is some particular reason for this data, which means that the alternative might be true.
Okay, I understand. Thank you very much.
Okay. Thank you so much, Deepan. I'm afraid we would have to
Okay.
Stop here. Thank you so much for that detailed um detailed lecture and everything. It was really it was well detailed, and I wish we had more time. And I believe that as many that are here, they've been able to learn one or two things from here. I believe it's the that's the distance for everyone here. And so we would quickly, because we're a little bit behind time, we would move to the next section.
I have a question.
Which would be taking your question. We would have to, you can type it in the inbox. Is it something you must say because we are behind time, at least 5 20 minutes? Is it something very personal you have to ask me? Can you type it in the chat box so that someone responds to it? Or is it something you have to explain verbally?
It's something I've already typed it initially, but the answer I was given, I'm not satisfied with the response and it's not detailed. That's why I really want to ask. Thank you.
Okay, ask it. Go ahead.
Thank you for a wonderful presentation. We learned a lot from this presentation. Great opportunity and excitement during this presentation. I can say a lot of kudos to all the organizers of this presentation. My question is, there's something that is confusing me in statistics. Whenever I carried out the data analysis using either one way another or two way another, there's a concept called one error and two error. So I want to know the clear distinction between one error and two error. And also, I want to know when a person omits type 1 and type 2 error. And what are the factors that leads to, type 1 error and type 2 error? And after all these two errors have been omitted, what are the possible way out? What are the solutions? What are you gonna do to, clean the mess at the end of the day so that?
Hello.
Okay, I don't know if you got his question. I think it's
I think it will take some time, but I can give you a simple example. What he's asking, I don't know. Like, when can we say whether it is type 1? I think he's asking what is a clear definition of type 1 error and type 2 error, isn't it, right?
Then how to rectify it, what comes about, what is responsible for it, what leads to those errors, and how you can solve those errors, fix those errors. I think that's the summary of what it is.
Okay. So,
how do those errors come about, and how can you fix it?
So, how this error may arise? So basically, we are defining this error in terms of the hypothesis. Maybe you can say your analysis. The results is showing true and false. Okay, but the actual truth must be something hidden that we don't know, that we want to find it, right? So there is also true and false. Okay, and if your result is giving true and the actual truth is also true, then no problem. Okay, no problem. Okay, and your result is giving false, the actual truth is also false, and then no problem. Okay, if your result is giving truth but the actual truth is false, then that is error. And you are giving a false, the result is giving false but the thing is actually true, is the error. So here in this case, what you are doing is this is the type 2 error. Like it means that you are actually rejecting a null hypothesis by saying that the alternative is true. Okay, so well, I'm just a little bit confused on what I have written. Okay, we can answer this later after some time.
Okay, so can we go ahead to the next section?
Okay.
Yeah.
It's because
So,
I'm a little bit tired also now.
okay. Okay, so would be going to the next section, which is and I think Deepan, I think you and Deepan and John is going to be taking this part. So would you like John to go first before you, so you could take a break?
Maybe I can start now.
Well, the next section is Introduction Object-Oriented Programming Systems and Concepts. Programming System Concepts in Python. So would you start and then John take continue?
Since this session took more time, if you need to take out some time and have some break and then we come back, I think we can do that too.
Okay, so let's recess of 10 minutes.
Yeah, so I mean, like switching
We're going to be back in 10 minutes.
Data structures and introduction to data structures. So, but let's see if he's going to take or John is going to come in. If not, we can move to data structures and then we'll come back to object-oriented programming.
Okay, so for that, you and Solomon will be taking it, right?
Yes. Solomon, are you there?
Okay. Solomon, Etiyeme, Promise.
Yes.
Please, can you hear us?
So
I think he's on the call, but
okay. Okay, I just sent him an email. We've actually been in touch, so I'll take this part and then he will come in and take the hands-on session. So thank you very much.
Okay, thank you so much. And so you have is you will try to go within the time frame. I know it can be interesting and we can't cover so much within the short period of time.
Yes.
But
so slides are very short, so we are going to take less time. And then Solomon.
And thank you for joining us all the way from your country. I mean, I know it's late or early. I don't know what time it is in the
All
US,
right, it's still night.
Thank you so much for joining.
It's still night.
Are you see?
Yes.
Okay.
Okay, so I'm going to share my screen right away.
Okay, thank you. Please go ahead.
I think my screen is being shared. Okay, so there we go. I think everything is set now. I'm sorry, it's still night here, so I woke up. I didn't sleep actually. So my background is still like in the night time. So, but we have to take this session. So I'm going to take the first part, and then my colleague is going to come to take the second part. So the first part is just to go into explaining what data structures mean, and also what are the data structures in Python. I'm just going to give the basics. I'm not going to go deep. My colleague is going to take more on that, the hands-on skills, and he's going to explain more about that. So who are we? We are a team of instructors and teaching assistants. So if you check our groups, we posted our pictures there. So we felt there was like no need of showing our faces here. So if you want to know us, just visit our platforms, visit our LinkedIn, and you'll be able to know us. So for this session, we're going to be looking at the definition of Python and its applications, benefits of Python programming, types of data structures, and then we have types of data structures, types of Python's functions, and then data structures in Python. These are the few things we're going to be looking at in this session. And just like I said earlier, we touch some of the very basics, and then we leave the rest for the hands-on session. So why Python? Python is an interpreted object-oriented high-level programming language. It is one of the most popular languages out there, programming languages out there. It has very wide applications in different areas. And just as we had our talk yesterday, we emphasized on the need for you to focus on Python, Python, Python. And today also, we are telling you that Python is a way to go. So anywhere you are, look at Python. If you are trying to learn a language, Python is very easy. We know our programming is also very easy, but if you're looking at going into machine learning and AI, you have to know Python. You can't do without Python. And that's why we're encouraging you to do that. So what are the areas of application of Python? Python has different areas of application. Different libraries are being applied in different areas. Data manipulation, you use libraries like pandas. Pandas, you use it to explore your data. NumPy, polars, and all that. So these are some of the Python libraries you use in data manipulation. We have data visualization, where you use Plotly, Matplotlib, Seaborn, and other Python libraries. And through that, you're able to visualize your data. And yesterday, we spoke about the need for you to do data visualization and manipulation or data analysis before going into machine learning modeling. If you don't do that, you may make a lot of mistakes, and your model may have low accuracy, and you may go into a lot of errors that you would have avoided if data visualization was done. So it's very important that you know this, and you know that Python is one of the languages. We know that people use R Studio. I've used R Studio for some time, using base plots and ggplots. I've done that using R, but then I enjoy using Python more than any other language. You can easily visualize your data using Python libraries. Statistical analysis. We did basic statistics just a while ago, and our instructor was showing us the Google Colab on how you can execute the cells and everything there. You can see that what is written there is in Python. So statistical analysis, we have some specific packages, specific libraries like SciPy, stat models that are used in statistical data analysis. Nowadays, people are not focusing on R. People use R, people use other languages to do that, but Python has proven to be one of the languages that is very easy to learn. You don't need to go and learn a lot of things in C++, or C before coming to Python. You can just start learning Python today, and you can code right today. Machine learning applications also. We have JAX, Keras, we have Tsenum, we have XGBoost, Scikit-learn, TensorFlow, PyTorch. These are some of the libraries we use in machine learning. We also have natural language processing. We have a lot of packages there, libraries there that we use in natural language processing, and we listed them there. The BATH models is one of the libraries that is popularly used. We have database operations, PySpark, Dask, Hadoop, and all that. Time series analysis, scikit-time, DATS, Prophet, TS-Fresh, and all that. We have web scraping, Beauty Soup, Selenium, and all that. These are some of the libraries and applications of Python. With all this, it is just telling you that you can't do without Python in our age. The benefits of Python, just as we listed the applications, here we added a few more. Apart from data visualization, data analysis, you also have automation. You have artificial intelligence. And yesterday we gave you the branches of artificial intelligence. We emphasized that when you talk about artificial intelligence, you are not just talking about machine learning. We have different areas of application. We have computer vision and other branches. We have large language models. We have generative AI. We have interpretable AI. All these are branches of artificial intelligence. And you can't work with them without Python. Python is one of the languages that is used in doing that. Software development, prototyping, web applications, machine learning, system scripting, workflows, mathematics, web development on the server side. These are some of the benefits of Python. With this, we need to know the data structures that we have in Python. How do we use Python? What are the data structures in Python? On a general note, we have different data structures. And these data structures are not just found in R programming. If you go to Python programming, you find these data structures. So when we talk about general data structures, we're not just focusing on one programming language. These data structures are found in different other programming languages too. You go to C++, you go to C, you go to MATLAB, these data structures are found there. You need to use these data structures. So these are the different types of data structures we have. We have primitive and non-primitive data structures. The primitive data structures are the basic data structures we have. Just as the name implies, primitive. Primitive means basic. Primitive in our own little way of understanding, primitive in our own culture, in different cultures, could mean something that is very basic, something that is not advanced. When you say this man is primitive, it means his level of civilization is not as compared to other people. So he's talking about the basic. So when we talk about primitive data structures, we're talking about basic data structures we have, not just in Python, but in other languages too. And it holds just a single value. We have examples of primitive data structures: integers, float, string, Boolean. In the next slide, we'll be looking more into these examples. You will know what integers mean, you will know what float means, string, and Boolean. But have it at the back of your mind that primitive data structures represent basic data structures. They are not complex, they are just very basic. And they hold a single value. On the other side, we have non-primitive data structures. And these non-primitive data structures are complex data structures. Some people name them as compound. They are complex data structures. It means they can hold more than a single value. They hold multiple values. And these non-primitive data structures are classified into two. We have built-in data structures, and we have user-defined data structures. Built-in data structures are built in Python. When we talk about Python, if we come to our use case, because we're talking about Python, these data structures are built in Python. If we talk about R, we will say these data structures are built in R. If we talk about other data structures, we say these data structures are built in that programming language. But for our own case, we are focusing on Python. And when we talk about building cases, building data structures, it means these data structures are built in Python and you can use it. You don't need to define it. You don't need to start from the scratch. They have already been built in the software, in Python software. When you talk about user-defined, when you talk about building functions or building data structures, we're talking about list, tuples, set, dictionary. These are examples of data structures that are built in Python and in other programming languages. When you talk about user-defined, you're talking about stock, queue, tree, graphs, and all this. And these are user-defined. You define them based on your need. Now, we talk more about types of Python functions. What are different types of Python functions? We have built-in functions, and we explained it earlier that there are functions that are built in Python. We have user-defined, we have Lambda, we have recursion. These are Python functions we have. And on the right side, you will see here that we listed some of the functions, especially on list. If you are using list, we showed here on how you can insert an element at a specified index, how you can append an element towards the end of the list, how you can sort a list in place. These functions are built-in. You can just say append, and you just show where you want to append, and that is done. These functions are built-in functions. Now, we spoke about basic data structures and complex data structures. As part of the basic data structures, which we are going to be using on and on, what do they represent? When you talk about Boolean or bool, what do they mean? Boolean represent true or false statements. If something is true or false, it means that kind of data structure that you have is a Boolean. If there are integers, it means there are counting numbers. And we have examples just as you see here on the screen. We have float. Float could represent decimals. We have 4.2 is just a typical example that we have. We have string. String represent characters. And then complex, which could mean that you have both counting numbers and other characters. And then on the right, we get some examples of functions that we have. But then as we move into the section of hands-on, we'll be talking more about that. Now, what are the characteristics of Python data structures? First, we have list, tuples, dictionary, and set. List allows us to duplicate their members. They are changeable, they are ordered, and you represent them by square bracket. And you must know, when you see this square bracket in Python, what do they represent? List. you must know their differences. You must know you must know the representation of list from tuples to dictionary and set. For tuples, we use round brackets. For dictionary, we use curly brackets. And then for set, we have curly brackets again. So these are just some of the characteristics we have. For tuples, they also allow duplicate members. They are not changeable. When we say something is changeable, we say it's mutable. So when we say lists are mutable, it means they are changeable. They can be they can be changed. The list can be altered. Tuples, not changeable. It means they are immutable. They cannot be changed. Dictionary, they are changeable and indexed. And sets cannot be changed, but can be added, and they are not indexed. As we move into the hands-on session, we explore more on this. And then if you have questions from there, we take them. Thank you. So Solomon, are you there to come in the hands-on session?
Yeah, while we wait for him, we can take some questions. I think
All right, so are you there, Solomon?
not on the call yet, but if there are questions, they can ask while we wait for him to come in.
Okay, so we can still move into another session while we bring in on board so that we don't we keep the time, and then we can still come back to the session.
Okay, so Deepan, are you ready for your question? You and Jen.
Did you call me? Hello?
Yes. I said, are you ready for your section now? You, John?
Yes.
Are you going first? Okay, please go ahead. So Deepan will be taking the next programming system concept and Python, and John too also will be John Agama Agbo. So Deepan, please go ahead.
Is my screen visible?
Yeah, we can see it.
Is it okay?
I think it's clear now.
Okay. Is this fine? Like, are you able to see my screen?
Yes, we can see it.
Okay.
That's it.
Okay, so let's have some discussion about programming. So maybe if you don't know anything about programming, can say simply as it is some set of instructions that you're going to give the microprocessor or CPU of a computer to achieve some output. Okay, but the thing is that you cannot communicate to the microprocessor as you doing with some human beings. because they are they can understand only binaries. Okay, in that case, what we are using is called a high level programming language, where we will give some instructions in terms something like a English, and that will be converted to some low level programming language, and finally the binary machine code and that will be implemented by the processor. All right. Right. So in a nutshell, we can say programming is about communicating with computers to make them do what we want. It's like mostly processing some input and then getting some desired output. Okay. So in the background, what is actually happening is that you should not think that this data will be very much helpful for a statistician alone, a statistician or a data scientist. It will be very helpful for a computer science or scientist also. It's because uh, they want to know how we can get the data, how this microprocessor going to process it, and how is going to deliver the desirable output. You may be wondering, like, I'm playing games, watching movies, then using other softwares. How this can be related with data? Well, actually, whatever you are doing in computers are basically you can translate them into in the form of binaries, right? Basically, it represents something in numbers. Okay, so even if it is a game, the information will be transmitted to the microprocessor, and the processor will do the processing, and then you may give some command like clicking the button in your keyboard or something like that. That is the kind of data that will be given to the processor, and based on that the computer, the processor will process and then change the data of the other thing. Something maybe like a car, the car will turn left, turn right, or something like something like that. It's based on the processing of the data that is given from your commands from the keyboards. So I think here you can understand what kind of data processing is happening in your computer. So that's what I said. Data is not very much useful for not only for statistician and data scientists, even computer scientists also need the data. So basically, this process in short is called as IPO. It stands for input, process, and output. So what this actual computer programs are, there will be some data and you need to know what kind of process I'm going to do. And together we call it as programs. So you need to know what kind of process that we are doing or going to do, as well as we need the data and the things that like how we going to store the data, in what form it is. Like in the previous session you have seen something like a string and a list, tuples, dictionaries, sets, right? So those are the ways that we can store this data, and algorithms are how we going to process, like what are the series of steps that these data is going to transform the input and then get the desirable output. So the entire thing is called the programs. Okay, so in early days, you can see uh, this is Charles Babbage, who is considered to be the father of computer science. So the thing that we are facing today and in his time are more or less the same thing. Okay, in his time, the problem that they faced is that to make repeated calculations in like about numerical methods. Newton is forward interpolation, backward interpolation, divided difference. Those are the methods. In those we have to do some repeated calculations. Okay, and even if you are doing a single mistake in the previous step, you will end up in an error. Okay, so this is a quote from him. He just said that I wish to God these calculations have been executed by Steam. So this is the reason why he start to build the idea for a computer. Basically, it's for executing a repeated calculation like this plus, minus, multiplication and all. Okay. Now I hope you understand what is this data and what is the process that we are doing, how the data is stored, where the program comes into place. Like, okay. And even in modern days, we are doing We are building algorithms to process the data. It can be image data, or it can be processing a video or a text. We are writing programs to how we going to process the information. Okay, that is the problem that we are facing today. And in his time, they will be very much involved in building something called, this log tables, right? Logarithm tables. So the logarithm tables is not just any magic book that is come from the heaven. Okay, so basically people use these kind of interpolation techniques and then found the intermediate values based on the existing data, and then that's how they just build the log function, the log table, and all. That's what I said. Even if there is a single mistake is happening, that will mess up the entire table. That's why he just said that I wish to God these calculations have been made by Steam. Steam in the sense it is like a air, okay, hot air. And this course is about object-oriented programming, isn't it? So in programming, there are different styles and ways. Okay, some of the popular programming styles are imperative programming, procedural programming, functional programming, declarative programming, and object-oriented programming. I'm not going to detail of these any other programming styles. We will just focus only on this object-oriented programming. Okay, so how they may differ from one another? It depends on the structure and the features and how it is implemented. The way of implementation makes the difference. Okay. So the first object-oriented programming is called Simula, which emerged around 1960. It was designed by a mathematician named Kristen and a computer scientist named Johan Dahl, and both of them are from Norway. The thing is that the Kristen is very poor at programming, where at the time John is a very high-level computer scientist of that day. So he hired him, and then they, because Kristen is a mathematician, right? So he wants to do a lot of simulation. Simulation in the sense they will have some mathematical model, and then they try to see whether this something they will generate some dummy data, like whether it is working or not. That is what call it as simulation. So he have the mathematical ideas, and together with the computational thinking of John Dahl, they designed the object-oriented programming. I mean, language that is similar. Okay, it is very much helpful for simulation purposes. Now we can see what is an object and a class. Okay, we can think of something like a car. So this car will have a properties as well as a method. In object-oriented language, what we call it as attributes and functions. Okay, so what is a property of a car? You can find the car's number is like AD47483, and the color of the car is blue, and the company is Mercedes, the model is CLK, and the gear type is something like automatic. And what this car can do is the functions. Okay, previously the property corresponds to the attribute, and the methods corresponds to the function. So the car can move forward, the car can move backward, right, left, and then stop. These are the functions of the car, right? So likewise, each and every object will have this kind of property as well as the method. It will have some basic attribute by themselves, as well as it will have some functions also. Okay, so the object is more or less like a user defined data type, and it consists of data members. All the data will be present inside the class. Okay, and then it's more or less like a blueprint for object. Okay, and the objects are like a product of the blueprint. Like simply you can call these objects or an instance of a class. Instance means based on the blueprint you produce to some objects. That is why it's called the product of the blueprint. Okay, so that is what the class and object is all about. To understand this, we have the popular game Tetris, and you can find a movie in the name of Tetris also. It's very much interesting. And if you see each and every block will have some 3 attributes or properties. One is that what is their rotation, what is the shape, what is the color. Okay, basically this represents the properties of the particular block. This is the particular block, right? So what may be the behavior, what kind of functions this block can do? So the block should fall, and then it can move sideways, and then we can rotate it. These are kind of action, right? So that's why we call it as a function. But in programming perspective, you should call it as methods. In Python or everything, we call it as methods. Okay. So it's time for you to think in terms of building a object-oriented logic for this game. Okay. You can imagine all these things as an object. The background is object. And then you see this space shuttle is also object, and its bullet is also object, and the enemies thing is also kind of object. Okay. So can you name some of the properties for this object? Like you can say the color of the object, and then you can say what is the health. Like the hero will get some bullets from the enemies also, no? So he will have some health points. So if he is getting some attack from the others, the health points will go. And then we have another attribute, like what is the score of the player. That will be tracked here, and number of lives. And these are the attributes that is available for this object. Okay, what kind of properties that we can, I mean, the functions, the methods that we can give to this object? Maybe we can make this shuttle to move left and right, and then if we click one button like enter or spacebar, that should trigger the attack, right? So the attack is a kind of function for this object. And then even the bullets, that is the laser beams that is coming out of this thing, even that can be object, because even that is also in the screen. Maybe you can create a program like in some constant time intervals, these objects should be created. You can see there is a equal time gap between all these things, right? And then how can we say whether this bullet will clash this enemy's spaceship? We can have a position, like you can have an attribute like position of this bullet that may represent some coordinates, some x comma y. And the space shuttle will also have some points like their coordinates. It will also have some x comma y. So we need to create a program that it will check if the bullet's position and the spaceship position are same, then in that case the spaceship should be destroyed. So that kind of logic that we can make. So if the spaceship is destroyed, we can increment the attribute of the player. The player will also have that score, no? That will be incremented by some 10 points or 15 points. Okay. If any of the attack from the enemies that is coincide with the position of the player, in that case, the player spaceship should be destroyed. In that case, that will decrement the player's number of life. Here it shows 2 lives are there, no? It will be, in future, it will be reduced by 1. And maybe his health can be reduced. So this is the basic logic of how these classes and the objects are working. But we need to know why we need a class and object. That is the important questions, right? So the thing is that you can see there are some repetitive objects that is in the screen. Like you just need one single blueprint that can be used to produce different spaceships. There is a similarity among them. And the bullets, you just need to create one single program, and based on that single program, you can create multiple objects of the same bullet, and that will be produced after some equal amount of time. So that's why we are having these gaps equally. Okay, so we can see some advantages and disadvantages of object oriented programming. It's about the maintenance. You see, if there is any bug is happening or arriving in some objects, you can just directly, if there is any bug in the space shuttle, you can directly go to the class of the space shuttle, and then if you fix the bug, then you can rectify the bug in the objects, right? So if you correct the blueprint, everything will change in the object. Okay. The code reusability. You don't need to write the code again and again for this newly created objects, right? You just need to create only one single blueprint. Based on that, you can create multiple objects based on that. And better problem solving. So in the case of this kind of space shuttle thing, right? There are many use cases for that. So in the particular cases, we need to find a better problem solving methods. So in that case, this object oriented programming will be very much helpful. And some of the disadvantages that sometimes this object oriented programming may be very complicated for a beginner. So there is a steeper learning curve, which means that people don't prefer to or prefer to learn this object oriented program. And increased complexity. If you're building a very large application, you'll be having a lot of blueprints, and you will not be able to find where the mistake is happening, what is the object that is related with that, and what is the corresponding class. It will be very much complicated. So when the program is getting so much large, this object oriented programming can be uh, less helpful. And performance overhead, which means that the performance of the program will be reduced. It's because we are actually doing so much abstractions in the sense we are just covering up and working on some top layers, not on the interior part, and not working with the deep down microprocessors. Okay, in that case, the performance of the program will be reduced. And these are the top 9 object-oriented programming languages. And you can find Java is the most popular object-oriented programming language. C#. If you find in Windows, you may be experienced with a lot of applications, right? You will find some Windows and it will have some buttons. And most of the applications in Windows is made of this C#. And then Python. If you see, everything in Python is object. I mean, it's a object-oriented language. If you see, you are using some methods like split or length, that maybe in the previous session you have seen something like a len or index for a list. There are so many functions for a particular data type, right? And those functions in object oriented language, it is called as methods. Okay, so everything in Python is a method. So in the case of statistics, we have seen the df dot value underscore count is a method for the object that is df. Okay, the data frame is the class. Okay, that particular data frame having our objects, I mean having our data or the objects, and you can just call this method, and then that method will give the corresponding output for that particular data. Okay, and you have other data, I mean the programming languages like Ruby, PHP, TypeScript, Kotlin, R, and Shift. Okay, so these are some popular languages, and this is all about the introduction to object oriented programming. And the upcoming, I mean the further concepts in object oriented programming will be covered by John. John is there. Hello.
Please, are you here?
So far, do you have any doubts? Hello. If you have any doubts, you can ask me.
It seems John is not here. I don't know. So should we go ahead and share his part? Did you prepare together?
No, actually, we split up the work, and then he said he will cover that things.
Okay. So John, are you there?
I don't think it's on. Maybe we could take a few questions and then we move to the next section.
All right, so maybe Deepan, do you have the Jupyter notebook for the object-oriented programming?
No, actually I focused only on the introduction part. Yes. Maybe I can show this one simple example for understanding the object-oriented programming in Python. So if I run this cell, you can.
So can I say something?
Yes.
So John was basically to cover the four the four concepts, the inheritance, polymorphism, and
Yes,
the rest.
yes, yeah.
Yeah, so if you can just highlight those ones, like the examples, or explain them, I think that will be done. That was just those four that he was to cover.
So I think there are four concepts, right?
Yes.
So maybe I can show this example to you. So what we have created is a variable, and then this is the assignment operator, and we are storing this data, that is hello, inside the variable, that is s. Okay, inside the variable, that is s. Now this variable is like a space in the memory that will have our data. Okay, I'm trying to find what is the type of this variable, and there is a function in Python called type, and then I'm printing it, and it is returning me a thing called class string. Okay, so as I said earlier, this Python is full of objects and classes, so that's why we can see this name classes every time. Okay, and if you check for something like uh, a data frame, maybe we having, so we have a data frame, right? So if I use the type of, see, it is giving me that it is a pandas data frame. So likewise, these are basically the classes. It's like a blueprint for everything that is happening in the Python, and based on that, the new objects, this df is a specific object that is holding our personal data. Okay, but generally the person who developed this pandas library will have that blueprint. So based on the blueprint, we are just creating the newer objects. Okay, so what about the methods that maybe you can see in the top? Like I used a thing called shape, dot shape, right? See, I used a dot shape. So what is the difference between a method and attribute is that you should not use this parenthesis. Okay, so when I'm running this one, it will throw me an error. Okay, it means that there is no function like shape. Okay, you cannot call this shape because it is not a function in a blueprint. In that particular blueprint, the shape is not a function, but anyway it represents a property. Okay, so what kind of property it represents? It represents the number of rows and number of columns. Okay, that's why we are getting 150,7. Okay, and when it comes to functions, if you see, I'm using a thing called head, right? Okay, so head has parentheses. What now I'm going to do is I'm going to remove it and then I'm running it. So this is actually a class. Okay, this is not at all it is a name of the function. It is not the class is df. Okay, that thing, it is the name of the function. That's why it is telling that this function returns the first n rows for object based on position. Okay, so to make the function working, we need to add this parenthesis and then run it. And now it is doing some process and then it is giving out you the results. Okay. So you don't know how to create a class, right? I think this will give you the answer. Okay. So you can see these are the things that is around this object-oriented programming. The first one is that you should understand what is a class in Python. I said it is a blueprint. And what is the object? It is like a product of the blueprints. And we're going to see all these concepts soon. And this is how you have to declare a class. First thing is that in Python, you should use a keyword called class, and then you have to write the name of the class. Okay, that's very important. Okay, maybe I can create a class, something like a dog, and I should use the keyword to let Python to know that this is a class. Please consider this as a class. Okay, so by this class keyword, I'm telling that the name of the class is dog, and I'm telling pass, which means that I'm not going to tell anything. I'm just skipping out all this content. Okay, it's just for running the program without the error. So that's why they are using the keyword called pass. Okay, so the name of the class is dog, and the keyword is class. And then how can we create an object? So you can create an object just by calling the class and then store it in the variable. In the case of this pandas data frame, you can see this all methods will be stored in the class blueprint, right? What I'm doing is that I'm creating a data frame uh, with the help of the function uh, in pandas. Now our object is ready here. This data frame is a kind of object, and if you want to see, you can, the objects will have that methods, no? So you just need to call that methods, and then you can use its attributes. That is what I said about the car, the properties as well as the functions that is within that objects. Okay, and then this is a thing called constructor. So each and every class should have a constructor. So you can have anything in your class, under your class, but the first thing is that you should have a constructor. Constructor is nothing but a function. It should start with the definition of the function, that is def. This is a keyword, and then you should use this one, that is that init. Okay, this is a keyword for the constructor, where the self represents your own object. Okay, and whatever parameters that you want to give can be given after that. Okay, now after that, if you see dog, give the name, it will create a object. The name of the object is Roger, and if you give the name to this class, a new object Tommy will be created. Okay, so then maybe you can add some functions. I said the first function should be the constructor, and after that you can create any function you want. So in the case of df, we have seen the dot head parenthesis, right? So likewise, they are using speak as a function. Okay, you can see that they are calling the function just like we have called that df dot head. So you can see here that is dot speak. Okay, so when you call this function, the program will type that is my name is Roger, and similarly my name is Tommy. And I hope you are able to understand how the functions and attributes are working. Okay, so now we can move on to the inheritance. Okay, so what is inheritance? Inheritance is about you just need to move on some of the properties and function that is present in one entity to another entity. Say for example, you are son of your dad, which means that his genetic materials are there in your body. Okay, say for example, I have something like I have defined a blueprint for a user account for a bank. Okay. And the account can be either a current account or a savings account. So saving account is basically for some normal people, and then current account is for business people. Okay. But any account will have the name of the person, will have the contact address of the person, and what is the amount that is holding in that particular account. Okay. And all these things are very primary for having an account, right? So these things, these attributes and these methods will be put it in the parent class. And what I'm going to do is to create a new class. I'm going to just inherit the properties of the parent class, which means that I'm going to take his genetic material to for this kid or some children. The children is here is the current saving account. Okay. But all the saving account will have the username, password, and then the bank balance, everything is same as a normal user account. So here what you are doing is your reusability of the code. You don't need to write new codes and to make the program very much longer. Okay, that is the advantage here. And then there is different types of inheritance. You have single inheritance, multiple inheritance, hierarchical inheritance, multiple inheritance. Okay. And then you can have an example over here, like how uh, uh, this inheritance is happening. You can define a basic thing. A person is the parent class. And if you want to create employee, you just need to know basically all the persons will have a name, they will have an ID number, and then if you can create some methods like display the name, display the details, you can get just declare the function and then you can get the output. But if you want to make that person is a most generalized term, right? To make them as an employee, you just need to add what is their salary, what is their post, what is their designation. If you add them, you will make that person class as a employee class. But the thing is that you are not repeating any code that you used in the parent, I mean the person class. So that is the advantage, that we are not repeating the code. What we are actually doing is we just need to call that previous class inside this class. Okay, you can find this person inside the employee, right? So if I create an object with the employee class, I am giving his name as Ragul and his ID number, his salary, his designation as intern. And you can see that I'm calling A dot A is the object name. Okay, so we are using the blueprint, and based on the blueprint, we have created an object and then asking the object to use this function display. Now try to find where this display is located. Display is currently located in the person, not in the employee, right? So which means that we are inherited both the attributes as well as the functions, the method. So even if you have called the employee class, still you can use the display function that is present in the person's class. Okay, so that's why it is working without throwing an error. And even you can use details that is present in the employee class. So this is what the process called inheritance. What is polymorphism? Polymorphism means that you can create different objects. Object in the sense you can transform a single entity into multiple things. In the case of inheritance, we have transformed a single user account into a current account as well as the savings account, right? The same thing, you just need to define what is a bird, and then the bird basically can fly and it can give an intro, right? So in that case, you can use the same bird class with the name sparrow, and then you just going to change one of its natural function. Here you can see that most of the birds can fly but cannot but some cannot. Okay. And if you are changing the that interior function just by calling the same function name, you are actually modifying the bird class without modifying it, but you are creating a new class called sparrow. Okay, which means that polymorphism. Morphism means that you are changing it. I mean, you can change in any number of ways. That is why you use the term polymorphism. Okay, so the class sparrow, ostrich, you're just changing it. Okay, but still you can use all the functions available in the bird class. Okay, if I'm creating an object like bird and then sparrow and then ostrich, and if I call the function intro for the bird class, I mean the bird object, it will give me what is present in the intro. That is, there are many types of birds. So you can see there are many types of birds. Okay, and then the bird class flight. What is written in the bird class flight? Most of the birds can fly, but some cannot. You can see that is written here. Okay, and thirdly, sparrow. So sparrow intro, because we have inherited the properties from the parent class, that is the bird class. So, and we did any modification in the intro function, right? So that's why it will take the original intro function from the bird, and then it will return. There are many types of birds you can find here. Okay, but we have modified the function of the sparrow, right? So that's why it is giving out the sparrows can fly. Okay, and similarly for ostrich, the intro will be same because of the inheritance property. And then the ostrich flight, we have changed the function, so it is giving a different output. So what we are actually doing is we are changing the original parent class without changing it. That's why it's called polymorphism. Okay, so now we have seen what is inheritance and polymorphism. What is encapsulation? Encapsulation is that you can, like in the example of that spaceship, no, we are not writing separate variables and then some functions separately for each and every enemy spaceship, right? What we are actually doing is put everything in one class, right? Put everything in one class, and we don't need to rewrite the same codes, right? So for each and every object, the data will be present for separately for each and every object. So we don't need to focus on rewriting the codes. Okay, so what we are actually doing is we are putting the variables and the methods into one single capsule and then make it very much usable. That's the process is called encapsulation. Okay, and the last one is called the data abstraction. So you maybe think of a lot of, if you see the class, it will have a lot of functions. Maybe you know that pandas is a library that I have shown you, and matplotlib is another one library, right? If I open the pandas GitHub page, you can find a lot of things that is working in the background. Okay, and if you check out their documentation, so this is the documentation for the pandas library. So what actually it is about, you can see there is a lot of things about data frames. If you open data frames, you can find a lot of variety of things that is the background. You can see a lot of methods that is available for the pandas library, right? But when you are using pandas, you are not able to see everything, right? You don't need to copy thousands of lines of code into your in your Google Colab and then start working, right? You are not at all doing those things, which means that we have create a abstraction. Abstraction means something that is we are just hiding this kind of messy part and make something so much cool. Say for example, the person who invented the car first, he will just exposed everything, like this is the engine, this is the gear, everything will shows very explicitly, right? But that won't be very much user friendly. You have to make it user friendly by putting some additional over layer that the user cannot see what is happening in the background, right? So that process is called abstraction. And what we have seen now is we have seen what is a class, objects, and what is the advantages and disadvantages and the concepts that is around this object oriented programming. And those are this inheritance, and then abstraction, and then polymorphism, and then the last one is the what it is, encapsulation, right? And this is the basic introduction to object-oriented program.
Okay, thank you so much, Deepan. This was thank you so much for your presentation. Thank you very much. And we must be exhausted already. Thank you so much. Quickly before if you have a question, you can drop in the chat box. But while we're doing that, I would like to call on the instructor to finish up the hands-on section for the first section. With the section before this, introduction to data structure, would be finishing up with the hands-on section. So please, Luper, you can present. You can start your presentation. Control the.
All right. Okay. Thank you. So, all right.
But while he's done, if you have a question, please drop it in the chat box, and Deepan and any other person will respond to it as soon as they can.
Yes, we have TAs here. We've taken basic statistics. We've had object-oriented programming. If you have questions, drop in the chat box. And you saw where Deepan went and got those resources, and I think Deepan can drop that link too. And then if you want to explore that, you can do that. And we are going to send you all these links too, and also all the materials we're using for this training. So you can go ahead and try to follow up. Then we have the last session. I took out some time ago to give you some basics on the types of data structures we have. We looked at the primitive, which are basic data structures. And then we looked at the we looked at the ones that are non-primitive, the ones that are complex data structures. We saw those examples and we did all that. So this session, someone was supposed to take it. We couldn't connect with him. So I'm going to go ahead to share my screen, and then we'll go on from there. So I think before we move on, if you are not so conversant with Jupyter Notebook, I will just go back a little bit and show you how you can launch your Jupyter Notebook. So you have Jupyter Notebook. So Deepan was using Google Colab. So we have IDE where you can use those IDEs are just places or workplaces where you can do your coding projects. We have those workspaces. So Google Colab is just provided by Google, and you can be able to go there, and they have, just like he was showing you, that you can use it for free. It's actually for free. And sometimes the space there is quite good, and you can run some analysis there or even some modeling. You can do that. But then if you have some more computational need, that's when the computational server comes in. If you don't have that need, you can use either your VS Code. I can go here and use the VS Code. I can just open on my laptop. I'm just showing you two ways. Working locally on your computer. If you're using Mac operating system, you have this VS Code. You can just go here, and because I want to open a particular file, is located on the downloads. I can go here and I will look at the file I want to open. This is the Jupyter notebook that I want to open, and then I click there, and then I open the Jupyter notebook. This I've opened. If I want to yes, I can expand it this way. If I had more files here, they will show, but I don't have more files. And then if I want to have my command line to show down here, I can just come here. There's my command line. So, well, I just wanted to show you that you can actually open this. If you have a Mac operating system, you can open this on Mac and you'll be able to run it. I don't actually want to work here. Yeah, I work here all the time, but I just wanted to show you we are going to work with Jupyter Notebook. We're going to launch it and then we use that environment. But this is just where you can work effectively, and then you can work and save everything you want to do here. I think it's based on my sharing that I wasn't able to find that, but yes, you can do that. So this is just one of the ways. And then if you want to open this using your command line, this is why we're saying you need to know how to use share scripting and all that. So this is my command line. So I'm going to type Jupyter Notebook. If you have Miniconda, if you have like Miniconda or you have an Anaconda on your laptop, that is where Python is being installed. If I just type Conda, it opens. So it shows this Conda environment and all that. It brings the Conda instructions and all that. So if I want to, but I already have everything I need. I have Miniconda, I have Python. If I want to work with Python, I can just type Python and then I can start working with Python, just Python. And I can just type this 1 + 1. And if I execute it, you can see it's 2. If I type 2 multiplied by 3, okay, 3 multiplied by 3, what am I going to have? I'm going to have 9. I'm working in Python. So, but if I don't want this, because I don't want to work in this environment, I already installed everything. I'll just go to Jupyter Notebook and then I'll continue working from there. So if I want to launch Jupyter Notebook, I've already installed it. I don't need to install anything. I've already installed all the packages I need, all the scikit-learn, all the pandas, and all the packages I need that we sent to you. I've already installed them. I just launch it and see what happens. It has opened to my browser. You can see it open. And then I want to go to my downloads because the file is located under downloads. And then under downloads, this is a Python variables data types I want to open. And then there I click and I've opened it. So here I'm working locally on my computer. So if I want to, so I can read through everything. So we get the primitive data types as integers, float, Boolean, string, and all that. And then we gave examples of containers. That's the non-primitive, the ones that are more complex, list, tuples, dictionary. So we are going to be looking at some of these things in this tutorial. So storing information using variables is one of the things we are going to be looking at. How do you store data in Python? We have variables, we have value. What are variables? And when we talk about a value, what does a value mean? We won't be able to complete all that because we have the machine learning class, which is going to come up later on. So we just touch the basics. And then we'll look at primitive data types in Python, integer, float, Boolean, none, and string. Building data structures in Python, list, tuple, and dictionary. And then methods and operators supported by building functions in Python. These are the key things we are going to be doing. And we will share this Jupyter notebook with you after this training. So storing information using variables. How do you store data in Python? How do you store data such that you can come back and use that data for what you want to do? Or you can use that data and train your machine learning model. How do you store that data? You store that data in form of variables. So the way data is stored in Python is called variables. You create a variable and you define it. You attach a value to it. So that's basically what you do. And that's just basically what we're talking about here. So you store it, and you can think of variables as containers. Containers for storing data. So you are conversant with containers. So if you know what containers means, it shows that it's containing something. If you have a container, just a container, you know the container is not empty. The container has something in it. So in Python, that container is what we are calling as variables. And not just in Python, if you go to other programming languages, it's the same thing. When we say something is variables, what do we mean? And then what is it storing? What is the content? What is the content in that variable? The content in that variable is what we are calling as a value. And this value could be numerical. When we say value, we don't mean it must be counting numbers. In maths or in some quarters, when we talk about values, sometimes you may feel value. It's just like counting numbers or like just natural numbers. No. When we talk about value, when we talk about storing value in Python or in other programming languages, what we mean is the content in the variable. It could be numbers, it could be float, you know, it could be all these other data types that we talk about. It could be a list. It could be a list of full stuff. It could be a string, it could be this and that. So you need to know that the content is what we are calling as value. And creating variables in Python is pretty easy. You can do that. Here, I want to say my favorite color. I just want to do this. And in Python, we use underscore. Most times you don't use like just this. If I use my hyphen favorite color, and then maybe I use this, let's see what it's going to bring. It's going to give you some syntax error. Cannot assign expression here. Maybe you meant equal instead of equal. So it's showing you some errors. It's because you are using a minus, you are using a hyphen instead of using an underscore. So these are some of the common things. We will talk about the operators we may not have all the time, but we'll push this to you. And then on the group, on our platforms, we have all the tutorials and all the materials we share. So if you put this as underscore, let's see what happens. These are the simple things that you need to know. You see, there it goes. And no error occurred. I ran the code, just Control Enter. Control Enter, and it goes. If you're using Mac, just Command Enter. That's how to run the code, how to run the command. But then if you also want to, let me just show you some of the basics. If you want to enter a cell, we have what we call Markdown, and we have what we call code. This cell is for code, is for running a code. You can see it's different. If I want to change this, if I want to, this one is not for code. This one is for text, and that's a Markdown cell. This is a Markdown. So if you click on Markdown, this one is just for content. It's not for coding. If you do Control Enter, it's going to give you this. If you double click on it, it's going to show you how this thing was typed. So you need to know the difference between Markdown cells and code, and then also raw. You need to know those differences. In most cases, you'll be using code and Markdown. And to comment, you use, if I want to comment on this cell, if I don't use this hash command, it's going to give me an error. But using this command, I can say how to, I can just say how to save a value. And then I run the cell and it runs. You can see it was 3, now it's 4. If I run again, you can see it has gone to 5, no error. But if I don't include this, it's going to have some error. You see, there's an error there. So these are some of the very basic things that you need to know. Very basic, but very important. If I want to enter a new cell, I can just come here. There is a way you can do it. There are different shortcuts. I use Mac operating system. So there are a lot of differences if you're using Windows or if you're using Ubuntu Linux. They are all different. So I wouldn't use the short commands on my own laptop because it's going to differ from the one you're using. But if I want to enter a new cell, I click here, and then you see cells. You can enter new cells. You can enter a new cell either below or above. And you can also do, you can delete, you can paste, you can do all that. So, and then if I want to run a cell, I can decide to run a cell over here, run a cell. You can run a whole, the whole notebook. This whole notebook, I can run everything. I can run some selected cells. I can run just a single cell if I want to do that. So these are the basic things that you need to know. And everything is hidden. So you see, and then if you just type my favorite color, is because you've saved my favorite, this blue, you've saved it in this variable. Your variable is my favorite color. You save this value, this blue, in it. So if you just type my favorite color, it's going to print out the content. It's going to print out the content in this variable. This variable that is called my favorite color. And then to save, I think you can do that. And then I will just give one more example, and then I'll move to another thing. Here you can save, you have this magenta color. You want to save it in different variables. And your variables are color 4, color 5, color 6. If you want to save this in each of these, that's to ensure that this magenta goes into each of these, is saved in each of these. You can just do this, and then you enter, and it is saved. If you want to print it in this cell, in color 4, it's printing magenta. In color 5, you want to print it, it's going to print magenta. If it's in this, it's also going to print magenta. So that is it. If you want to save all these colors in these variables, you can save red. You can save red. If you want to save red in color 1, green in color 2, blue in color 3, you can actually do that by just separating it by commas. You can see color 1, color 2, color 3. You just separated them by commas. And here too, you separated them by commas, and then you run the cell. So red will be saved in color 1. Green will be saved in color 2. You can see. If you print this content, is green, you are going to see. If you print color 3, what you're going to see is blue. So this is just the basic on how to save. And we have a lot of more, we have more examples on how to save. Time will not permit us to do that, but we will push this to you. You can go through this, it's very easy. You can easily understand it. And then we move down to another thing, building functions in Python. Here I've saved my age. My age is 29. I am 29 years old, not my real age. So you need to know that. I am 29 years old. And this means that 29 is saved in my age. My age is my variable. I'm saving this value, this 29, in my variable, my age. If I run the cell, I've saved it. Once you do it as command enter or control enter, depends on the laptop you're using or the operating system you're using. But again, if it's not in underscore, you can see I will have an error. I will have a syntax error. But if I have it in underscore, you can easily do that. So these are the very basic things you need to know. Wish we have more time to go more into it, but we'll be trying to round up. We'll be moving very fast in the next very few minutes. Time is up already, but we'll just take a few more minutes to complete this. So you can just run that. And then my favorite car is this. I'm saving this value in this variable. You run it, and that goes. You can see this is this. Who can tell us what this means? Is this a string, or is this a Boolean, or is this a list? Okay, I don't have to mention list. Is this a string or is it a Boolean?
It's a string.
It's a string. Someone has clearly told us that it's a string. It has characters. You can see that when we talk about value, it's not just talking about numerical values. When we're talking about 29, yes, it's a value, but it doesn't mean that it's just a numerical value. That's not what it means. Values means it could be a string, it could be an array, it could be, it can also, you can see here we have a Boolean. You can see, is today Saturday? Yes, it's true. Today is Saturday. And you are saving this true in this. If I want to say false, I can say false. And you see, false is already saved. It's an inbuilt. And once you type it, you can see green appearing. When you see numbers 29 appearing, 29 means, you can see, this means it's already in this dictionary. All these numbers are already inbuilt. This Boolean is already inbuilt. So you can see false appears. If I want to just start typing false, and then you save it there. And then the three learners, Ruben, Victor, Favor. Who can tell us what this is? What is this data structure? Is it a list? Is it what?
It's a list.
This is a list.
Yes, it is.
A list of what?
A list of strings.
A list of string. A list of string. This is a list. It's very easy. List. Just list your names. That's just what it means. And then is a string because it has characters. These are characters. R is a character. E, these are alphabets. When we say characters, we mean alphabets. So this is a string of characters. So you are saving this in this. You run it, and that goes. So this is just a few examples we have. If I want to print this, I have 29. If I want to print type my age, that's the type of this data structure. If you want to check what this data structure means, you have this variable, and your variable is my age. Your value is 29. You want to know what this data structure represents. This 29, you don't know it. Just assume that you don't know that it's an integer. Just don't think that we told you it's an integer. You want to print it. You want to know whether it's an integer, it's a string, or it's a boolean. It's a bool. You want to check. You can just simply type, and then my age. That's your variable. This type is already inbuilt. So once you type this, it's going to print out this data type. And the data type for this is an integer. So this is an integer. You can still print this data type. You don't need to do anything. Just print it. It's a bool. It's a boolean. Because today is Saturday, what does that mean? The value you saved in this today is today's Saturday. What you saved in it was what? Was false. It was true before. I'm going to put it back as true. And this is automatically being saved. So you don't need to go and save it anywhere. Once you are running this, it's being saved. So I'm saying I'm running this cell and it's saving. Today is Saturday, true, it's Saturday. And then I'm running this cell, and even though it's not printing that true, but it's already saved. And since it's already saved in this, it can tell me that what is saved in it is a boolean. Is either true or false. Is today Saturday? Yes, it's Saturday. And what is the data type? I'm trying to check the data type, and it's telling me it's a bool. And then my favorite car. My favorite car is what? Is this. And then I'm trying to print it. I'm printing this, and it's giving me string. str is a short form for string. int is a short form for integer. And then bool is for boolean. So these are the basic things that you need to know. I have this. This is a list. Someone told us that it's a list. I have this list of names. It's a list of string. So I'm going to print this data type, and it's a list. And it goes on and on. If it's a tuple, how do you know it's a tuple? Okay, we have the seed learners, and you have all this. Time will not permit us to do all that, but you have all this in this notebook. Integers, I've already explained. I don't need to explain integers to you again. Float, we mentioned float. Float can contain decimal points. And this is a typical example of a float. One of the things that will help you is to know the difference between float, string, boolean, and all this. When we're talking about integers, you should be able to know this. They should be at your fingertips. And you can print the data type, and then it gives you as a float. You are printing this 3.4 is a pi. 3.14 is a standard, is a pi, is the standard, the numerical value for pi. And then you print it. And when you print it, in fact, when you print it, and then you want to check the data type, it's giving you as a float. As a float. A float means it has decimal points. Floating point numbers are numbers with a decimal point. You can see time will not permit me to read all this. But if we push this to you and you spend time to read this and to go over and over, ask questions, we are here to answer you. You can continue asking questions in the comment box. Our members are there to answer you. Our TAs are there to answer you. You will know everything. This is not rocket science. These are things that are very easy for you to know. time will not permit us to go on and on. But you see, 3.0 is what? It's a float. It's 3. If you just type 3. It's going to print 3.0, and 3.0 is a float. So this goes on and on and on. Time will not permit us to do all that, but we just want to show you that these things are very easy. And then it goes on and on. This is a Boolean. And we talk about Boolean. We will not go over it again. It's true or false? Yes. And these are the operations we did. And we have all that. And then none. None means nothing. You are saving none in nothing. This is your variable, and this is your value. Your value is none. And this is it. This is a data type. And if you want to print what is in nothing, what is in this variable, it's going to print none, because you saved earlier on, you saved none in this variable. And then if you want to print a data type, it's going to print none type. This is what it means. And then we go to string. We talked about string before. That string represent characters, alphabets. And then you print it, and it goes on and on. So time will not permit us to do that again, but these are examples you can play around with. We'll push this to you, and after this session, we're going to push this to you. Feel free to ask questions. And I think Deepan is also going to put the links in the chat box, the link to the resources he used. And I'm going to do that too. Immediately after this session, we're going to do that. And then it goes on and on. And index. Okay, so index, we have to start from somewhere before we go there. Index is okay, we have list. We needed to start from somewhere. I think fruits, yes. This is where we needed to start. So you have this list. This is a list of fruits. And then you print out these apples, banana, and cherry. So we will be running out very soon, but if you feel hungry, we are already in break time, we're already in lunch. So we'll soon be running up. We just want to take this session because it's very important. I think we are finding it very interesting because it's very easy. It looks as if rocket science, but it's very easy. Sister Esther, are you there?
Yes, I'm here.
All right, so what are you giving me?
Okay, are you done with us yet?
So I think I still need some couple of minutes to run down to touch the very basics. I'm just
okay. I will just give you a few minutes.
All right, thank you.
So just use a few minutes to fill.
Okay, so now you have this list of fruits: apples, banana, and cherry. And earlier on, we showed you what this bracket. What is this bracket? I'm going to be asking questions now because we had that training. So when we showed you, when we shared those slides, we were telling you what this bracket means, this square bracket, this and that. So for list, what type of bracket do we use in list? Who can tell us? It is right here. Who can tell us this?
That is in parentheses.
Okay.
Sorry?
Yes, you can go ahead. Any other
square brackets. The square bracket.
We use a square bracket in list. Yeah.
It's okay. Square bracket. So now you see we have square bracket. We're using in list. So you need to know the specifics. You need to know all this. When we're using other data structures, we weren't using that. You can see we have all this square bracket, you see, empty list, you see tuples, you see them here, and we gave everything here. So you need to know all this. These are the very basics that you need to know before moving into complex things. And then we just move on. I just want to touch about this because I think it's very important. then you print these fruits, the list of fruits. You print the data type is list. And then you are looking at, let's try creating a list containing values of different data types. So a list of this, and this list contains, what is this? Who can tell us this? Did I print it? I think, oh, no. So who can tell us what this means? 23 is what data type?
Integer.
Integer. What about this one? Hello.
String.
None.
String. Not.
None. Yes, it's none. What about this? 3 point.
That is float.
Float.
That's float.
What about
String. No, it's a string.
That's no string. That's variable.
String.
Okay, what about this? 3 is less than or equal to 5.
That's Boolean.
3 is less or equal to 5.
That's a Boolean.
So now we have this list. And you print this list, and it prints all this. And you see it has printed true. 3 is less or equal to 5. It's because it's true. 3 is less. It's less than 5. So, and then it has printed true. And that's why that person got it as a Boolean, because Boolean is either true or false. So you need to know all these basics because it's very important. And then you have an empty list. Here is an empty list. This is the square bracket, but then there is nothing in it. And then you try to print it, and it prints an empty list. It's an empty list because there's nothing in it. So we have that, and then to determine the number of values in a list, use the len function. You can use len to determine the number of values in several other data types. So you have these fruits. This is what it says. This is what is in this. And then if you just use len, and then you put fruits, that's a variable. It's going to tell you the number of values. That is the number of items that has been saved in fruits. This, earlier on in this, we already saved it. So it's already in their dictionary. It's already in the Python dictionary that these apples, banana, and cherry were saved in fruits. You can see it's not now. We saved it before now, but it's already in their memory. So once you just type fruits, it's going to print out what was saved there. And that is why it's very easy that you save something from the beginning of your work, but then when you write like 100 lines of code, you can still print out what you saved earlier. So it helps you to keep track of your work. And then you know the data frames you are working with. You know the important data frames, and you know the ones that you don't use maybe in your training. If I'm doing exploratory data analysis, and maybe I try to handle my missing values, then I create a data frame, and that data frame is all maybe I'm calling as a variable, and I save it. And then in another way, I saved something that the missing values weren't treated. I can easily pick the one that the missing values were treated. Where the missing values, maybe where I had missing values, I represented them all with non-availables, or I inputted them with something like maybe zeros or something. That is the kind of data structure I'm going to use. So it's very important that you note that you are saving this in a Python dictionary. And that is why when we mention dictionary, we're talking about saving this in Python. So you print out this, you see, you say you have 1, 2, 3. And then when you say len, you are printing what? You are printing a number of values. These are the values you saved, and this is a list. This is a list of string, just like we spoke about it earlier. And then is as printed 3 because you have apples, banana, and cherry. It's very easy. And this len is already in the Python building function. It's not something that you need to do and on your own. So it's already built-in function. And then you move on, and you have number of fruits. Okay, print number of fruits. So this is a print function. Print number of fruits, and the len has a number of items saved in fruits. The number of fruits saved in this fruits is 3. So this is what it's going to print. And then it's going to print a number of items saved in that. And then here you have a mixture of different data types too. And you have, if you count it, you have 1, 2, 3, 4, and then you have 5 and 6. Don't count this. Count this as a single value. Don't count it. Don't count each of them as a value, because don't count this as 3 values. They are not. This is just a string. This is just a list of string. You can see this square bracket. It's just telling you that the whole of this is just 1. So you are counting it as 1. And then you have 2, you have 3, you have 4, you have 5, you have 6. You are printing this list. And then if you want to know the length, I don't even need to print this. I can just say len a list, len variable, and then it's going to print out this 6. And then it goes on and on. If you want to print an empty list, it gives you 0, because an empty list is empty. There's nothing in it. And then we come to indexing. We come to indexing. You can access an element. I think indexing is very important. And after indexing, I think I will stop there, because indexing touch arrays and all that. So I wouldn't continue from there. So Sister, you can just watch the time, and then once I finish this, we can just end, and then we'll push the notebook to them to continue to the end. Then you have these fruits. You have this value saved in this variable. This variable is called fruits. And you have this value saved in it. Apple, banana, cherry. These are the variables saved in it. And then you want to print the first item that has been saved in these fruits. The first item is denoted as 0. You start counting from 0. From O, 0, 1, 2, 3, 4. So if I'm going to count these, I'm not going to count apple as 1. My numbering is going to start from 0. So apple will represent 0. That is what is called index. So you're counting in this. Anytime we talk about counting or representing this, their specific positions, we're talking about index. So I'm going to introduce a new term to you, index. You can access any element from the list using index. So the fruit returns the element at index 2 within the list fruits. The starting index of a list is 0. So the starting index is 0. The index, remember, is telling you the positions where you can access it, at what position. I know we have a lot to do on how to add, how to remove, and how to do all that is contained in this notebook. Time will not permit us to do that, but you can explore it. And if you have questions, we're here to answer you. But know that if I want to print the first item in this, I'll just type 0. I don't need to type apple. I'll just type 0, and it's going to print apple. You can say I just type 0. If I want to print the second item, I'll type 1. And then I'll print this. You can see I've printed banana. If I want to print the third item, I'm not going to type 3. I'm going to type 2, because I started my index at 0. 0 as the first item, 1 as the second, third, and it counts. You continue counting in that order. And then I'm going to put 2. And when I put 2 and I run the cell, you can see it has brought out cherry. What if I put 3? Let's see what happens. It brings a syntax error. List index out of range. It's out of range because you don't have any other item apart from this cherry. You have only 3. So it's going to give you an error because you are trying to print the 4th item, which doesn't exist. And this is a counting based on index. The counting based on index starts with 0, 1, 2, 3. So if you do this and you are trying to print, know that you're not doing the right thing. Your counting is wrong. You are starting your index with 1, of which 1 is not the first index. 1 is a second index. That's 1 is a second item. It's a second at the second position. So you need to know this. And then if I want to print back the first item, which I did, you see it's going to bring apple. And then I did all this. I think this is it, this is it, this is it. What if I put -1? What is it going to print? -1 is going to print the last item. -1 is going to print the last item. So -1 in index means the last item. And then you continue in that order. -1, -2, -3. It's going to be printing it backwards. It's going to be printing it backwards. So I have cherry. This is cherry. I have printed cherry. And then I have -2. Oh, what did I just do? All right. So I'm going to print banana. That's the second index. That's counting from the end backwards. It's going to print banana because banana is here in the second position. I'm starting my counting from the end. And this is how, if you want to add an item, you use these two. If you want to remove an item from your dictionary, that's from what you've saved. You also do that. And then the last thing is you are trying to print this first item. This is -3. What if I try to print like going behind like the 4th item, like say -4? What is it going to bring? Syntax error, out of range. What if it is 0? -0. Does -0 exist? Let's see. -0 printed what? Apple. -0 printed apple. And this is starting from the beginning. So if you want to start from the beginning, it's going to have that. And what if it's just going to print the first item? And what if I print 4 was out of range, and this was originally 3. So I'm going to bring it back to 3, and it's going to print apple. So you need to know this. And it continues on. And I think here we're just talking about the index error and all that. So I've already covered this, out of range and all that. I won't be talking about that. I think I've already covered this too, -1. Well, you can go over this. And then we have this on. And then I will show you, if we had more time, I will show you how to update values in list. How to update values. Sister Esther, can you give me 2 more minutes?
Okay, 2 minutes. So that means you're finishing by 12:30.
Yes. I want to touch a little bit about the updating values in the list. It's very important. So you have this list, and you have this list. You printed your first item. You printed your second item here. Your second item is supposed to be what? Banana. Remember your index. Your first index is 0, and then you are printing your second index, which is banana. Your third index, and then you can also change the value at a specific index within a list using the assignment operation. So the assignment operation here, we are trying to add this blueberry. And at what position are we trying to add this blueberry? Second. See it here. Blueberry is not on this list. Is it here? No. We are just trying to add this blueberry at what position? At the second position. Remember, at the second position. Remember, it's not the first. First starts with 0. But we are starting, we want to add it at the second position. And then once we do that, let's add it. And then you print it, you see, blueberry has taken the place of this banana. And where is the banana? It's no longer there. You want to update mango with the third position. That's for cherry. Let's try it. And you see, mango has replaced cherry. And that goes on and on. And then if we had more time, we'll talk about how to update this list from the end down to the first. But our time is up. And then we have list methods and we have all that. And we have it goes on and on. And this is just one of the notebooks we have. We have other notebooks that we're pushing to you to practice and see how that goes. How do you find it? Any questions? I think I'm done. Thank you very much.
Thank you so much. Thank you so much. I believe everyone present here has been enjoying this section so far. Can you just quickly type something you've learned, or if it has been productive for you, if it has not been a waste of your time since yesterday till now? And we are moving gradually and almost getting close to the end. Thank you so much for an amazing time. If you have questions, you can please drop the questions in the comments section, where we are slightly behind, not slightly, we are actually behind time a lot. So we would have to stop right now. But before we move on, please don't forget to take the attendance. And we are going to go in on a break, a long break actually, so we can take a rest. You can eat. I know some persons are they've been eating behind the scene, but now you can eat without hiding. You can eat, you can go and rest. We are going to come back where the break is supposed to be for 2 hours, but I'm going to be reducing it to 1 hour 40 minutes. So we're going to be coming back in 1 hour 40 minutes, and this is 12:32. So we would come back around. Let me calculate this. This is 12 by 1:32. That would be okay. We would come back exactly around. We're supposed to come back around 2.
Yes, 2
Actually, that would be 2 hours.
Yes.
2 p.m. So, but because we are behind time, and because because we reduced our time, we're going to come back around 2:10 instead. So, exactly 2:10 we would be back. So please, you can, for those of us that are in our group, you can drop your questions there. We can be responding to them in our spare time there. There'll be people that will still be in the group responding to questions. If not, you can keep the question until later. We're going to have a general Q&A at the end of this section. Trust me, the last session is going to be even more interesting, and you're going to meet more instructors at that time. So, thank you so much for joining us that far. We are going to be stopping here, but quickly let us just pray and thank God for this section. Father, we thank you for bringing us thus far. Lord, even as we go to take a rest, Lord, we ask.
Hello.
Amen. You have something to say? Yeah, do you have something to say, Nathaniel? Yeah, I dropped the link so many times, and I'm going to drop it again.
Okay.
All right, so
Okay, I just dropped
we're
the
going to
link.
check. Yes, I'm going to check the point solution. A lot of people have actually done that. They've completed that. So if you haven't done that, you have the Google form as an alternative. But if you really want to participate, to do to take attendance on point solution, you can still go ahead and do that. We'll resume this. We'll resume the session. Yes.
Yeah, so we'll resume the session by 2:10.
You can go ahead and take attendance.
West African time. Yeah. So, but this meeting will be open for just a few minutes so that you can drop your questions, and it will be open for the next few minutes, and then we'll close the meeting officially.
And the link for the attendance.
You just dropped the ID. Yeah, you dropped the ID earlier for point solution. Maybe you
yes, I
should
dropped
drop
it
it
in
again.
the
I think
chat box. I can still drop it there.
Please drop it again, please.
Attendance is very important. So what we are, when we come back in the last session, we will still share the attendance list. We'll still share the link for the last session and also the point solution ID. We'll share it for the last session too. And we are making this, this is the first time, and we know a lot of you are just starting in it. So it's just the very basics. We understand about that. We'll push all the resources to you right away, and you will keep your hands working. So we're going to push all these materials for this morning session. Before you come for the second session, you will have all the materials. Thank you.
Sir.
Yes, you can go ahead.
Good afternoon, sir. I wish to appreciate you so much for this wonderful session. Please, I would like to get your email so that we interact with you after here. And I need a link so that we install that very Python you are using. Because I've tried using the other links, but they want to damage my laptop with a virus. So I wish to get the link that is verifiable that I will install it now.
Okay. So, all right. So you can contact us via our email. I just sent our email in the comment box. So you can contact us through that email. I could be the one to answer you. Any of our admins can be able to answer you. So
okay.
Then,
thank you, sir.
So is it Minicon that you want to install, or you are looking at installing what software do you use?
Yes, my piece, I used Anaconda before, but I've changed the laptop and I lost everything. So this one I'm using is called i5 500 hard disk and 64 operating system.
Yes, I know about that, but what I'm just asking is about the operating system. The operating system could be Windows. It can be
it's Windows 10, Windows 10 Pro.
Okay, Windows. So you want to install what on Windows?
Windows. So you can recommend the one that is fitting for this particular PC.
All right. So
the 64-bit processor is 2.4.
I will prepare Miniconda for you.
Okay, sir.
For Windows.
Okay, sir.
And then I'm going to send you the link in the chat box. Installing on Windows. I'm trying to get the Miniconda for you. So we have this. So for this link I'm sending to you is just for Miniconda, because Miniconda works perfectly, and then you'll be able to install it. Let me send this link, and I'll send you a second link too.
Okay, sir.
Are you okay? Are you the only person that is raising up his hand?
Let me take that.
Well,
okay.
Well.
Oh yes, Nsika, you're also raising up your hand.
Yeah. Good
So
afternoon.
let's finish with him, and then I'll attend to you. Miniconda. All right. So, and I'm sending you Miniconda because personally I don't know I was using Anaconda before, but somehow I preferred Miniconda. Doesn't give me any issues. I don't just know. So I just loved it and I use it for anything I want to do. It gives me, that's why sometimes maybe it's my own bias, but I love Miniconda. So I've sent you links to install Miniconda on Windows.
Thank you, sir.
So you go there and first thing you do is you download it. And then you can install it. And then you have the terminal, you have the terminal on your laptop, and then you can follow the other processes. If you need some more help, let us know, and we'll help you.
Sir, one more thing. Do I need to combine PyCharm with this Anaconda, or only it can give me the possible result?
So PyCharm is used for, it's just to check your code. I mean, for ensuring that your code is clean. So
okay, sir.
I think personally, that's what I use it for. I don't use it all the time. I use it, yes, but I don't use it all the time. So the most important thing you need for Python or for coding is just this Miniconda. And the Miniconda, once you're installing Miniconda, you know, the Python is there, the latest version of Python is there, except you want to install the specific version that you need. If you have a specific version that you want to install, then you can specify. If not, you are going to install the latest version. After you install, it comes with some dependencies. And then if there are any ones, then you need to fulfill. You can do that. But then you need to also install packages. So Python packages like pandas may not be there. So you need to check, how do I install Python packages? I'm going to send that link to you too. Installing, and you see how to install all the Python packages, installing Python packages. I'll just type Miniconda on Windows, but it's not even that very important. But I've seen installing Windows Conda documentation and all that. So you're going to have okay. All right. So what you can do is, instead of doing instead of just typing that, you can just type the specific library you want to install. Or if you are running a code and they say this is not available, you have to go and install it before you can continue with your with running the cells. So for instance, if I want to install pandas, I can just say installing installing pandas or install pandas. And then once you just type install pandas, you check the documentation. Be sure to go to the original documentation, and then you click on it, and you see for Miniconda, installing this pandas on Miniconda, conda create and it gives you Python pandas. And then you can create the environment and activate it. It's very easy. They get the code here and everything is there. Pip install pandas. That's how you can install it. So pip install this, install XGBoost, install other packages that you'll be needing. Matplotlib, if it's not there, you can install all these Python packages that are used in machine learning. I think with that, you'll be able to do that. Any other question from you, or that's all?
That's all. Thank you, sir.
You're welcome. All right. So, Sikan, are you still there?
Yeah, I'm here.
All right. So I'm going to take your question.
Okay. Good afternoon from here. Thank you for the seminar. And my question is on object-oriented programming.
Okay.
Yeah, I'm a bit of advanced learner.
Okay.
Now, you are developing a program.
Yes.
And you know, from what I saw today, like on inheritance.
Yes.
For instance, now you are developing a program, and say a big project, and all the classes will have different files.
Yes.
Now,
The
for
base
instance,
class,
now,
right, class one, and all that. Yes.
Let's say we have a class called student.
Yes.
In a particular file. Then you want to inherit from another class like faculty.
Yes.
That is in another file, not in the same file.
Yes.
Now, what was shown today?
Yes.
It was like the whole thing is in the same file, like the lesson while we're taking the OOP.
Yes.
It was on the same file. Now, assuming that these are classes that are in different files. Say I want to inherit from faculty. I'm developing a student class, and I want to inherit from faculty. That is in another file.
Yes, it's
that
just
I've developed already.
Yes, just like
So
it's a
yes,
sub or class inheriting like a super class or something.
Yes. So how do I get it from another file that I've developed already to the existing one that I'm working on? Did you get my question, sir?
So, are you looking at? Okay, I'm trying to understand the question. So, is it like a single case, single inheritance scenario, or it's multiple inheritance kind of thing?
Like a single inheritance, for instance, now. Say